Hi guys, we are going to start chapter 7.1 notes. So let's go ahead and get started. Chapter 7.1 is over ratio and proportions. So in example 1, it says a baseball player's batting average is the ratio of the number of bats hit to the number of at-bats, not including walks. The table at the right shows Ian Kinsler's career batting stats with the Texas Rangers. What is his batting average? So in order to find his batting average, we need to take the total number of hits and divide it by the total number of at-bats. So the total hits divided by the total at-bats. So the total number of hits we can see is 1145, and the total at-bats is 4201. So if we divide that on our calculator, we get 0.273. So this is our answer because this is his batting average. Okay. So now let's look at example 2. Example 2, we have to find the ratio of the measure of the angles in triangle 3, 4, 5. Find the measure of the angles. So just as the ratio 3/4 or 3/4 is equivalent to 3x over 4x or 3x 4x, the extended ratio can be written as 3/4 or 3x 4x 5x. So we're going to do just that. Well, 3x plus 4x plus 5x is going to give us a total angle degree of 180. So let's write that. 3x plus 2x plus 4x, not 2x, 3x plus 4x plus 5x, because I'm taking them all from here, is equal to 180. Well, 3x plus 4x plus 5x is 12x, equal to 180. If I divide by 12, I get x is equal to 15. So then I need to plug in 15 for each of these angles. So 3 times 15, 4 times 15, and 5 times 15. Well, 3 times 15 is 45, 4 times 15 is 60, and 5 times 15 is 75. So these are my answers because these are all the angles of each of these parts of the triangle. Okay. Hey, let's go over this key concept, cross products property. In a proportion, the product of the extremes equal the product of the means. For example, if A divided by B is equal to C divided by D, when B is not equal to 0 and D is not equal to 0, then we can cross multiply. So almost like the butterfly method, if you guys heard of that. So what we're going to do is we're going to cross multiply in this example. Okay. So we have 6 times 3.15 is equal to 21 times x. Now we just have to solve for x. Well, 6 times 31.5 is 189, equal to 21x. Divide by 21, we get x is equal to 9, and that's our answer. Let's do the same thing on this side. So 5 times x plus 3 is equal to 4x times 2. So here I have to distribute this 5 in. So 5x plus 15, and then 2 times 4 is 8x. Okay, so I'm going to subtract 5x to the other side, and I get 15 is equal to 3x. Divide by 3, x is equal to 5. Okay, pretty simple, huh? Okay. Look at this key concept, equivalent proportions. The following portions are equivalent. A over B is equal to C over D, B over A is equal to D over C, A over C is equal to B over D, and C over A is equal to D over B. So it's saying that in some cases we could flip this around, and no matter what, we're still going to cross multiply the same products. We're still going to multiply A times D, B times C. A times D, B times C. Same thing. So let's look at a real world problem. So it says Fernando conducted a survey of 50 students driving to school and found that 28 owned cars. If 755 students drove to school, predict the total of people who own cars. So we need to set up the proportion 28 over 50. So that's his first survey that he conducted. And then x over 755, because we don't know how many drivers and we're trying to find that. So let's cross multiply. 28 times 755 is equal to 50 times x. 28 times 755 is 21,140 equal to 50x. Divide by 50. We get x is equal to 422.8. So that means approximately 423 students own cars. And that's our answer. Okay, and that concludes the notes for 7.1.